Now let's take a look at the period. And I'm going to kind of take a look at the period based upon looking at a couple of graphs. So I'm going to graph and take a look at y equals sine t and y equals sine 2t. Now hopefully you recall that the sine t has a period that is 360 degrees or 2 pi radians. So if I take a look and I graph sine t, remember it intersects at the origin, intersects the x and y axis at the origin, and it rises, comes back down to the x-axis, falls, and comes back to the x-axis, and it does that in 2 pi radians or 360 degrees. I did the same thing with sine 2x or 2t, and notice when I do that, in the time it takes the sine to do one revolution, one cycle, we get sine 2x doing two of them. Notice it does one cycle in half of the sine function's period. So notice when graphing sine x, we get one complete cycle in 2 pi radians. When graphing sine 2x, we get two complete cycles. So we can actually generalize this to say that when we have y equals sine bx, and notice I didn't put the shift part in, that we get b complete cycles in 2 pi radians. So if we get b cycles in 2 pi radians, we get one cycle in 2 pi over b radians. So all I did was divide basically both sides of this statement by b. So b cycles in 2 pi radians, divide by b, I get one cycle in 2 pi over b radians. And remember, one cycle is the period. So the period is going to be 2 pi divided by b. Notice we put the b as being positive absolute value because we want to make sure that our cycle, our period, is a positive number. So the period we can compute by doing 2 pi over b. Now notice everything we've said about period, amplitude, and midline for the sine function is true for the cosine function as well.